Hey students, in this video I'm going to summarize inverse functions, basically recalling from Unit 7 when we learned about inverse functions. We learned here that inverse functions are graphs that reflect each other across the y equals x equations or line. We also learned that in a table, the values, the x and y values swap each other. So notice how these two tables have the x and y values swapped. And then the same thing happens if we analyze the points individually. The domain is all the x values and the range is all the y values. So when you do the inverse, you will have this x and y values swapped, which means that all these x values are now the y values, and all the y values here are now the x values. So the originals and the inverse swap in that way, and that's what it says right here, that we already know based on last unit. So bringing that back, we are going to now analyze exponential and logarithm specifically and understand how they also reverse each other because they're inverses of each other. So the original exponential has a graph that has a horizontal asymptote, and because that asymptote stops the graph from going up and down forever, it goes left and right forever, which is why the domain is all real numbers in negative infinity, positive infinity. The up and down is stopped by the asymptote, so this number that we see here comes from the asymptote because that's the limit. If we look at the inverse of that, we now have a vertical asymptote created, and the vertical asymptote stops the graph from going left and right, which is this domain having a limit based on the asymptote. So the range and the domain are, they're equal. They're pretty much the same thing. They swapped. So, and then the domain is now the range, where this is going up and down forever. So this happens algebraically when we rewrite the equations like we did in the previous lesson, where we were solving and undoing, reversing the logs and all that stuff. So now we're going to use that skill into rewriting inverses. So this is the steps. You replace the f of x with the y. You interchange x and y, so notice how they swapped. And then after that, you isolate the exponential. So this part had a -5 that needed to disappear. And it went the other side by adding 5 to both sides. It canceled on this side and then added over here. And then after that, we need to rewrite. We need to rewrite this exponential into a log, or in this case, this log into an exponential. So they swapped, kept the base and swapped the other parts. Then we are going to solve for y. So wherever the y value is, we're going to isolate it. And then that returns your function into now an inverse. So here we have an example that was graphed for us already. I went ahead and graphed this in a calculator. And then I traced the points to get these values of the table. So let me just show you. Here is the log base 2, that's the blue graph. And then the red one is the inverse. And then I drew the black one just to show you how it's across the reflection line. I'm gonna go to trace and show you how I got these points. So I started with the blue one, and I just had a y-intercept right there. And I just typed 1, enter, 2, enter, 3, enter, 4, enter. And then that showed me that 4, 3 was one of the whole numbers points on it. And then I went backwards to what happens on the left side of 0. So I went -1, -2, enter. And at -2, there was a whole number of -2, 1. So I got these 3 points. And I'm going to do the inverse of that, which is swapping them. So these points should be on the red line, or the red graph. So I'm going to show you that right here. At 2, 0 is one of them. And then at 3, enter, we have 3, 4. And then if I type 1, enter, we have 1, -2. So this confirms that these points are the inverse of that. So right here, something like that. And then I believe the asymptote for this will be here at -4. So it's kind of like that. All right, so we look at the domain for the original, meaning the yellow one right here. It's stopped by the asymptote. So we're going to say all x values greater than -4, because the asymptote is at -4, so anything further to the right. The range is all real numbers because it's going up and down forever, so we just kind of keep it like that. And then the domain for the inverse, which is the other one we see here, that one goes up and down, and it's stopped by the asymptote here, so it goes left and right forever. So this is all real numbers for domain. And for the range, we're going to say anything higher than -4. All right, so that's just confirming how the algebraic part needs to be practiced, because when you graph it, you can check that they are inverses like this. All right, so let's practice that. We start by writing this as y equals. Copy everything else down. And then we're going to swap the y and the x. We're going to swap them. So we're going to have x equals 5 to the y minus 1 and then -4. And we want to isolate for y. So we want to get this to be by itself first. So we're going to add 4. We're going to have x plus 4 equals 5 to the power of y minus 1. And we still want to solve for y, which means this cannot be touched unless we bring it down. So we're going to write log of base 5. Because right now we don't have a log, we're going to write a log to undo that part. And then these two parts switch. So we're going to have the argument of x plus 4 equals on this side or the other side, whichever side you prefer. So these two swap. And then now we want to isolate for y, which means that we need to add 1 to both sides to cancel this one. So the inverse function will have log of base 5, argument x plus 4, and then plus 1. And we can always graph this to check that they are reflecting across that line. So I'm going to clear it. I'm going to graph first y equals x, just so we can have that reflection line. And then I'm going to graph the original one, which is 5 to the power of x minus 1 minus 4. And now I'm going to graph the one we created, which is log base 5 x plus 4 and then plus 1. And there you go. It's a beautiful reflection over the line of y equals x. So this is the inverse of that. Let's practice it one more time. Well, actually 3 more times because we have 3 more examples below. Okay, so we're going to start with rewriting this as y equals. And then we're going to swap the y and x. So we're going to have x equals 8e to the negative y plus 1. And then we want to isolate this part. So we want to get rid of the 8 in the front by dividing by 8. Okay, so then now we're going to have this is a 1 in the front if there's no number. So this is technically a 1/8 x equals e to the negative y plus 1. Our goal is to get y by itself. We can't touch the exponent part until we undo the e. So the opposite of e will be writing ln and then swapping these two. So with the argument of 1/8 x, and then we're going to put that it equals negative y plus 1. So to get to the y by itself here, we need to get rid of the negative in the front. We can either divide by -1 or multiply by -1. So both of the sides get divided or multiplied by -1. And that leads to now having y plus 1 equals ln negative ln because of that negative division. And then 1/8 x. And we want to just have the y by itself, so we need to subtract 1 from both sides. And then we have y equals negative ln 1/8 x minus 1. So then that becomes the inverse, g negative 1x. So the inverse of g of x, negative ln 1/8 x minus 1. And you can graph and check. So I'm going to clear it, type the line of reflection first, just so we can see that it perfectly matches that. Then we graph the original, which is 8e, and then negative parentheses x plus 1, enter. And now we're going to graph the one we created, which is negative natural log of 1/8 x minus 1. And even though it doesn't seem like it's reflecting, let me move these out of the way. No, not that one. Let me retype that, sorry. Control divide. Okay. So I'm moving the equations out of the way so you can see how this part of the red is this part of the black, and this part of the red is this part of the black. So yeah, they're inverses of each other. All right, let me go ahead and move on to the next problem. Here we have rewriting this as y equals log of base 2 x plus 3 minus 8. Then we're going to swap the y and the x. So it's x equals log of base 2 y plus 3 minus 8. And we're trying to solve for y. So this needs to be isolated, which means we're going to add 8 to both sides. So x plus 8 equals log of base 2 y plus 3. And the y is inside the parentheses, so we have to undo the log. So now we're writing the base of 2. And then these two swapped. So 2 to the power of x plus 8 equals y plus 3. So if you start with the log, you need to end up with something to the power of x. If you start with exponential, then you end up with logs. So the last step here is to get the y by itself, which means we need to get rid of the plus 3, so minus 3 minus 3, that cancels, and we're left with the inverse of h of x equals 2 x plus 8 minus 3. So this is the inverse, and I'm going to go ahead and graph it just so we can see it. So clear it, type x. The original is log base 2. X plus 3 and minus 8. So that's the original one. And then the one we created is 2 to the power of x plus 8 minus 3. So I'm going to zoom out just so you can see it a little bit better. Notice how it is a replica of each other. All right, one more problem. I'm going to graph the reflection line. And then let's see what we get. All right, so the first thing is to rewrite this as y equals negative 1/2 ln x minus 3. Then we're going to swap x and y. So x equals negative 1/2 ln y minus 3. Then we need to isolate this. So we need to get rid of these two right here. And pandas backwards, we're going to get rid of this one first. So plus 3. So we are going to have x plus 3 equals negative 1/2 ln y. And then to get this by itself, we are going to get rid of negative 1/2. We can either divide or in this case multiply. If we multiply this times a negative, it gets rid of the negative, and then 1/2 times 2 will give you a whole number, which is 1. So we're going to multiply this also by negative 2. That will give us negative 2. We can do x plus 3 in parentheses equals ln y. And then we want to undo the ln because we want to get the y by itself. So we're going to write the base of e. And then these two are going to swap. So y equals, and then e to the power of negative 2x plus 3. So it's an exponent. And again, you cannot get this far if you don't practice the rewriting part. So I strongly encourage you to practice the previous notes. 8.5 and 8.6, become really, really good at that so you can have this be easy for you. All right, so let's graph that just to verify. The original is negative 1/2 ln x. So let's type that, negative 1/2 natural log x minus 3. And then the one we created was e to the power of negative 2 times x plus 3 in parentheses. And it should, or it does look sort of a replica of each other. For some reason the red looks like it stops, but it doesn't. It's just the asymptote is there. And then now the asymptote is horizontal in the black one. All right, so I hope these 4 problems help you practice the other 4 problems. Please, 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 practice makes perfect. So the more you do, the better for you. Hope this video helps you.